Hello, I'm Brian Diaz Gutierrez, and this is my final project video. For the first part of the assignment, I had to make a decision analysis application, and this is what I got. Okay. James wanted to start his own business, and he was torn between opening a cozy cafe or launching a flexible food truck. The cafe promised big profits if customers poured in, but it also carried the risk of losing money if demand was low. The food truck felt safer with steady, smaller earnings, leaving James with a tough but exciting choice about his future. This is the table that was given to me. So, uh, in case of a strong demand for an open cafe, you make $80,000. Open food truck, 40,000, and then it's a weak demand. You would make 20,000 for an open cafe, and then 10,000 for the food truck. And the probabilities are 6% for strong demand and 4% for weak demand. Okay, and now the type of decision problem is we are looking to find in which one he will make the biggest profit in, right? So for minimum, for best and worst payouts, for open cafe, minimum will be minimum of the open cafe option. For open food, for a food truck, it'd be the minimum. We would find the minimum options of the open food truck of both. And then the same thing, but for max, for the other side, when we're looking for maximum. Now, for best payoff, it will be the maximum of the strong demand for both, for for cafe or food truck, and then this would be the weakest demand, that the best payoff for weakest demand, right? For both. Okay, for opportunity loss, it would be the best payoff for um the strong demand minus the open cafe and strong demand. And this would be the same down here, but for food truck. And in this case, it be 10,000 minus the negative 20 from weakest demand of cafe. Now, for the decision strategies for aggressive strategy, it will be, since we're looking for a maximum objective, we'll maximize we're looking for maximum value out of the largest outcome value. So in this case, it will be the maximum, right, of the largest, which would be, and it would be this one. So it would be 80,000, which will make the aggressive strategy choose open cafe. Now, for conservative, it would be the maximum of the smallest. So it would be this one, right? Um, and then if we're looking for the maximum, it would be the 10,000 here. So the best payoff value would be 10,000, in which we would choose to open a food truck. And the opportunity loss would be the same one that it always is, minimum of the largest, right? Which in this case, it would be the 30,000, right? And we would open a cafe. It would tell us to open a cafe. For average, we would find, I decided to do, it said four, but I decided to do all five options to be, just to make sure that I was making the right decision. Now for the average, it'd be the average of cafe, restaurant, and week demand. Same for a food truck. And then we would choose which one we would like to open. We would open which would be the best option. And we'll have the less risk. So we would go to open a cafe. And for expected value strategy, um, we would it'd be some product of the cafe and then the probabilities, right? So that for open cafe, it'd be 40,000. And then for value for open food truck, it'd be 28,000. And we would choose to open a cafe. And here's my decision. So I would say to open a cafe. I feel like that's the better option for for this person, for James. Welcome back. For part two, we had to make a linear optimization application, and where I'd have to show you how to build a linear programming problem using either my own or the Panther Ice Fund, and I will be using the Panther Ice Fund. So first, maybe the question: Panther Ice Fund sells two snow skis models, paw and muscle. The manufacturing process requires fabricating and finishing. The fabrication department has 12 skilled workers, each of whom works 7 hours per day. The finishing department has 3 workers who also work 7 hours a shift. Each pair of PAWS skis require 3.5 labor hours in the fabrication department and 1 hour in finishing. The muscle model requires 4 labor hours in fabricating and 1.5 labor hours in finishing. The company operates 5 days per week. Panther Ice Fund makes a net profit of $50 on the PAW model and 65 on the muscle model. The company wants to determine how many of each model should be produced daily to maximize net profit. The company anticipates selling at least twice as many models as PAW models. Okay, so first I'm gonna write the input parameters, which should be profit, as it says that they make a net profit. No, profit, right? 50 in PAW and muscle, and 65 in muscle. And I'm gonna copy this over to here and here. Then another input would be fabricating time and finishing time. Fabricating time would be 3.5 for PAW, okay, 3.5 for PAW, and 4 for muzzle. And then finishing time would be one 1 hour for PAW and 1.5 for muzzle. And then we'll be looking for units to produce daily. And then for here, it'd be profit model. Okay, then we can delete this part. We'll use it, and right. And then for here, we would use, that's, we're looking for, here we'll be making the profit. So this would be sum, it would auto sum these two. And then here it'd be this, which should be the amount of money they make out of the profit that they make from selling these times the units we would need to produce. Then in here we'll just move it here and it will give you the same answer. Right? And then for the constraints, it's my hardest part. It says that we'll be fabricating the working time, right, for the workers. So fabricating working time, right, which would be, since it says that there's 12 working hours, 7 hours per day, we could say that the 12, it should be 84 hours. Now for finish, okay, wait. but we would go, since we're looking for 84 hours or less, since that's what they're working, we would go, right? And then here, it'd be, okay, it'd be equals to some product of this, comma, this. And then after, we would use finishing time. Mm-hmm. And it would be the same thing since there's 3 workers working 7 hours, right? We would go 3 times, which we all know this, but I'm just gonna do it so you can be more visual. 21, and it'd be the same. Wait, so okay, product here, comma here, right? And then here it says the company company anticipates selling at least twice as muscle models as Paul. So it would be, I'm not gonna write here because I do not know what to write, but we're going to go and I'm going to do this. Okay. This we're gonna make this one, right? Since we don't know what it manufacture. And then this we're gonna do here. Nope, not that. Like that. Okay. And then for the constraint, we would put, okay, put this times 2, right? So whatever we get for Paul, we will multiply times 2 because we would have to, right? And that's it. And then now we can go to data, solver, and then we can start. For set objective, it would be here, right? Which I forgot. So we would maximize, right? This is what we're gonna do. Maximize profit. And then here, this will be profit. Then now we can go to data solver. Okay. And then this will be profit by changing these cells, maximize, and then we can add the constraint. Okay. So we will go this. Mm-hmm. But the more or more than. Okay. And then the solving method will be simplex LP. And there we go. And this is how you do it. So the units we need to produce is produced for on, and then the units produced for muscle, and then profit. Just how we do it in class would be, these would be the units for Paul, these would be the units for muscle, right? And then these would be a profit. Thank you very much for coming to my TED Talk, and have